So, hello everyone. Today we are going to look at a very interesting uh, topic of stack. Okay, so today I'm going to discuss about stacks. Okay, let me just. Okay, so what is a stack? Uh, this we know, first in, last out, or last in, first out. Okay, so this is our stack. Now, the question that we have is nearest greatest element. Okay, NGE. Okay, so the question says that we are given an array. We are given with an array, let's say 3, 10, 2, 6, 15. Okay, we need to find the nearest greatest element to the right. Nearest greatest element to right. Nearest greatest NGR. Okay, for example, for this element 3, the nearest greatest element to the right is 10. Okay, so we'll have this another answer array. For 3 we have nearest greatest right is 10. For 10 the nearest greatest is 2, no. 6, no. It is 15. For 10 it will be 15. For 2 it is 6, nearest greatest, and for 6 it is 15, and for 15 it is nothing. So either we can put -1 or infinity or whatever we want. Okay. Okay, so how can we solve this question using stack? So let us wait a minute. Let me clear it up. Okay, so we all know how to implement stack. We have push operation, pop operation, and we have peek. Push means we will push an element into the stack. Pop means we will take out an element from stack. Peek means we will get the topmost element. We will not pop it out. We will just peek into the stack and we will see which is the topmost element. Okay, let's say this is the topmost element. We will just say okay, this is the topmost element, but don't pop it out. Okay, pop is not done here. Okay, we just check the topmost element. That's it. That is called peek. Okay, now let us take an array for ngr. Nearest greatest to the right. We have 3, 5, 6, 2, 11, and say 12. Okay, now we need to maintain a stack. What we will do, we have this indices 0, 1, 2, 3, 4, 5. Okay, and we will have one answer array 0, 1, 2, 3, 4, 5. 0, 1, 3, 4, 1, 5. Okay, so what we will do, at the last index we will simply say in the answer array, make it to be let's say infinity, or infinity in our Java or C++ will be math, or say int max. Int max will be our infinity. Okay, so just put infinity here and we will go to the next element. Here what we will do, we will and okay, and after doing this, let's say we put infinity here, and in the or from the original array we will just take this 12 element and put it in our stack. Okay, yeah, push it in our stack 12. Now we go to this 11th element. Now what we will do, we will check if 11 is less than the peak element, stack dot peak. Okay, we will check this. Sorry, if 11 is less than stack dot peak. If it is true, that means this element is greater than 11 and this element has come from the closest right, okay, the closest rightmost index, and that would be our answer for index 4. So we will just put 12 here. Okay, yep. Okay, and we will not take out 12 right now. Okay, no need to take out 12. 12 will be there as it is. Okay, now we will come back here, and for 2, and one more thing, we just put 12 here, and from the original array 11 we will just push 11 out here in the stack. Now we go back to 2, and again we check the peak element, which is 11, and 11 is greater than 2, so we'll just put 11 here on the third index for 2 and put 2 in the stack. Okay, now we come back here. Here what we see, we have 6 and the peak element is not greater than 6. Just take out 2. Okay, now again check the peak element. 11 is greater than 6. Yeah, it is greater than 6. So put 11 here and just put 6 in our stack. Now again we go back down. Here we have 5. 5 is less than 6. Yes. So 6 will be in our first index. Again we go back, and before going back put 5 in our stack. Now we have on the 0th index, and 0th index we have 3. So 5 is greater than 3. Obviously 5 is greater than 3. Put 5 here. And since we have reached our 0th index, there is no need to put 3 inside our stack, and just cross check what will be our answer. Hopefully answer would be this only. Okay, let us do it for some complex array. Okay, complex array means not array with too many elements, but array which has some edge cases. Okay, let's see what edge cases I'm talking about. Okay, let's say this is our stack. So we have 20, 1, 2, 5, 5, 4, 9 and 11. Okay, 0, 1, 2, 3, 4, 5, 6. Okay, and we have our stack here. We need a bigger stack, and this is our answer array. One, two, three, 4, 5 and 6. Okay, now what we need to do, we will start from the last element as we do for the nearest greatest to the right. Okay, for this one we will simply put what, infinity. Okay, and we will push this 11 into our stack. 11 gone there. Now we go back to 5. Now we have 9, and just see 11 is greater than 9, the topmost element of stack. Yeah, put 11 here, and before 11 here, and before going to 4th index put 9 in our stack. Okay, go back to 4th index. For 4th index topmost element is 9 in our stack, and 9 is greater than 4. Just put 9 in our answer array and push 4 in our stack. And now go back to 3rd index, Here we have 5. For 5, do we have the topmost element greater than 5? No. So remove it from stack. Pop it out. Popped it out. Now again check. Topmost element left is 9. Is 9 greater than 5? Obviously. Put 9 here. And push 5 in our stack. Now go back. Now we have 2. For 2, the topmost element is 5. 5 is greater than 2. Yes. Put 5 here. Put 5 here. And push 2 in our stack. To pushed. Now go back. For 1, topmost element is 2. 2 is greater than 1. Yes. Push 2 here. And push 1 in our stack. Now for 20. Now let's see. For 20, what we need to do. Do we have anything on the right greater than 20? No, not at all. But in our stack, we have so much element left. Okay. So we have this one popped out. This one popped out. And rest are there in our stack. Okay. So now what we'll do is 1 greater than 20. 1 is not greater than 20. Not greater than 20. Pop it out. 2, no. 5, no. Pop out. 9 is greater than 20. No, not at all. Pop it out. 11, no. Pop it out. So now what we are left with it, since stack is empty, simply we'll put infinity here. Okay. If our stack is empty and whatever element we have and nothing is on the right greater than it, so we'll just simply put infinity. So we have two infinities here. Okay. So that was the intuition, and for the coding solution I will put a next video for the code solution, or simply we can have a pseudocode here. Now for pseudocode, so one thing you can understand, for traversing in a stack we are running a while loop, and for traversing on our array we are running one for loop. Sorry, we are running a for loop from behind. Okay, from n-1 to 0, and from here while stack is not empty. Stack is not empty. Not empty. Okay. What does that mean? So given we will have a array and nothing else. Function. Okay. So what we need to do, we will first of all we will create an answer array of size this array only, int n. Okay. Then we will make a stack of type integer. Okay. Now we will run from nth index or n-1th index. For I is equals to n-1 to 0. Okay. Before that I forgot to do one more thing. So what we had, the last index will always be infinity. Okay. So for answer of n-1 will be int max. Okay. And we will push the last element of our original array. Let's say it will be 20. It is 1 2 3 4. For 20 we have the next greatest as infinity, but we need to push 20 in our stack. So stack dot push array of n-1, isn't it? This is n-1, this is n-2 dot dot dot, this is 0th index. Okay. Now we will run a for loop for I is equals to n-2. Why n-2? Because n-1 is already computed to 0. Now what we need to see, we will see if peak element of the stack peak is greater than, not equal to, only greater than, okay, is greater than array of ith index. Okay, if it is true, if it is true, that means we know that the last element, sorry, so the peak element of the stack, peak element is greater than the ith element of our original array. Simply we will do answer of I is equals to stack dot peak. Okay, and we will push the ith element of the original array into the stack. Okay, we'll push here. So what we will do, stack dot push array of ith index. Okay, this one is answer array and this one is our original array. Okay, now else what we will do, else we know this is not greater than this. So until, I need another space, in our else block, what we will do, while our topmost element in the array stack dot peak is less than or equal to our array of ith index, we will just remove it. Or and one more condition, while stack is not empty, stack dot empty. Okay, while stack is not empty, and this condition. Okay, we will just do stack dot pop. Okay, and after this we would have found one element which is not satisfying this index. Okay, but it might also be possible that our stack is empty. So first we will check if stack is empty. If it is empty, what we'll do, simply put maximum now. So answer of I is equal to int max. Else we know that stack is not empty, stack is not empty. So we had caught one element which is greater than array of ith index. Okay, so we'll do answer of I is equals to stack dot peak, and we will push the ith element of our array in our stack, stack dot push array of ith index. So that is what the solution looks like, and simply will return answer array. Okay, I hope this is understandable, whatever I have done. Else what we'll do, in the next video I'll just come out with the video solution. Okay, I hope it helps. Thank you for watching.